This is the next unit for Math 8. We're going to continue working with linear equations, but in a different way. If you recall, linear equations are graphs of straight lines. And they're in the form y equals mx plus b, where m is the slope and b is the y-intercept. So that's what we did for a while, and we're going to continue with that and talk about a few other things with it. So in example number 1, Lenore has purchased a tablet computer. She's considering purchasing an access plan so she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting, plus an amount for the number of minutes connected based upon a constant usage rate in dollars per minute. So what's going to happen is, when she logs on or connects, she's going to get charged a fee. Every minute she is on that wireless, she gets paid. She gets charged a certain amount. So she's considering this company's plan. The company's advertisement does not state how much the fixed access fee for connecting is, nor does it state the usage rate. However, somewhere in the company's website, it says that 10-minute session costs 40 cents, and 20-minute costs 70 cents, and a 30-minute is $1. So she decides she'll use these pieces of information to determine the fixed access fee and the usage rate. So for question number 1, there is a table here that she started. She makes a table of information in a graph where a number of minutes is represented by horizontal axis and total session cost by the vertical axis. So y is the cost, because the cost depends on the number of minutes that she uses. That's the dependent variable. Plot 3 given points. They appear to lie on a line. What information about the access plan suggests that the correct model is indeed a linear relationship? So 10 is 40 cents, 20 is 70, and 30 is $1. So if I were to connect these, I would get something that looks like this. So what makes it appear that it's indeed a linear relationship? Well, we know there is a constant rate of change because the line is straight. And another word for that is the slope is constant. So part 2, the rate of change describes how the total cost changes with respect to time. The number of minutes increases by 10. So when this goes up by 10 minutes, how much does the charge increase? So this goes up 30 cents for 10 minutes. That is how much it increases. Another way to say this would be the usage charge per 10 minutes of use. Use that information to determine the increase in cost based on only 1 minute of additional usage. In other words, find the usage rate per charge per minute of use. So I divide the 30 cents by the 10 minutes, and I get 3 cents per minute, which happens to be my slope. It's the rate of change. So question number 3, actually the next page is going to ask to continue the rest of the table. So if we notice this table is going up by 30 cents each time, so this is an extra 30 cents because it's 10 minutes. So this is $1.30, and 30 cents more is $1.60, and 30 cents more is $1.90. And likewise, if I go backwards, I'm going to take away 30 cents. So this is my initial startup fee, 10 cents you pay. Question number 3 also says to plot those points, and if you'll notice, those points will all be on the graph. That should be at the origin. Sorry, my marker is off a little bit. 40 is $1.30, which is right there, and you'll notice that they're all on the same continuous line. So number 3 we did. Number 4, using the table in the graph in exercise 1, complete the hypothetical cost for 0 minutes of use. What does that value represent in the context of the values that Lenore is trying to find out? So we found that 0 minutes, the cost was 10 cents. And what that value represents in the context is it's the initial connecting fee. And in terms of a linear equation, it happens to be the y-intercept, the starting value, which is b. On the graph in exercise 1, draw a line through the points representing 0 to 60 minutes of use under this company's plan. The slope of this line is equal to the rate of change. What in this case is the usage rate? We found the usage rate in the last page, where it happened to be 3 cents per minute was the slope, m. Using x for the number of minutes and y for the total cost, write a function to model the linear relationship between minutes of use and total cost. A function is an equation. It's something where you can input x values and get out the y values. So y, the total cost, is equal to, now this is mx plus b, that's how I write linear equations. So the slope we found was 3 cents per minute, times x, the number of minutes we use it, plus the initial startup fee, which is 10 cents. So my equation would be y equals 0.03x plus 10 cents. A second wireless access company has a similar method for computing its costs. Unlike the first company that Lenore was considering, this company explicitly states its access fee is 15 cents and its usage rate is 4 cents per minute. So they come out and tell you exactly what it is. Number 7, let x represent the number of minutes, y the total cost, construct a linear function that models it. So the total cost y is equal to 4 cents per minute, that's the slope right there, plus 15 cents, which is the y-intercept. So I just rewrote it where the y-intercept is at the end in terms of y and x. Number 8, using that, we're going to find the cost for 0, 10, 20, and so on. So what you're going to do, you're going to plug in, this is x, the number of minutes, and y is the cost. So you would simply plug in y equals 0.04, 0 for x, 0 minutes. And when you solve that, it's 15 cents for 0 minutes. And you continue doing that, and you're changing the number of minutes. So this would be 55 cents. And I could keep going, but I know what's happening is it goes up 40 cents each time. So this is going to be 95 cents. 40 more is $1.35. 40 more is $1.75. 215 and 255. So we can use that linear function to complete the table of values. Number 9, plot these points in the original graph. In what ways does the line that represents this company differ from the line that represents the first company? So I'm going to go back. Sorry, I keep flipping back. And I'm going to graph it on here. And, sorry, 15 cents to start, which is just above that one. And in here. So I'm going to kind of cheat here and take my straight edge. And this is what it would look like. So this is the second company here. And if you notice, if you compare them, it's a steeper slope, which means it's going to cost more per minute. And the starting value is a little higher also. So the line is higher. It costs more. And it's got a steeper slope. So what the steeper slope tells you is that the usage rate is higher. So not only does it cost more to start, it also costs more per minute. Question number 10, 11, and 12. 12 we're not going to graph it, but I'd like you to try 10 and 11. Read that scenario and see if you can come up with X is the songs downloaded and Y is the cost. So I'll get you started there. In number 13, a band will be paid a flat fee for playing a concert. Additionally, the band will receive a fixed amount for every ticket sold. 40 tickets, the band gets paid $200. 70 tickets, they get paid $260. Determine the rate of change. The rate of change is the slope. Define the slope, y2 minus y1 over x2 minus x1. That's what we've been doing for the past while now. And in this case, y is the amount of money, and x is the ticket. So 260 minus 200 over 70 minus 40, which is 60 over 30, so it's $2 per ticket is the slope. 14, write this as an initial linear function using x and y. In order to do that, I need to find 15, which is the y-intercept. So I know that it's going to be y equals $2 times x, but I don't know the initial fee. So to do that, I know each ticket is 2, so if I sold 40 tickets, and they're $2 a piece, that means I made $80 from the tickets. We're paying the band $200 though, so I subtract the 80 from the tickets, and I get 120, which is how much the band makes if no tickets are sold. So my equation would be y equals 2x plus 120. 16, how much will the band receive for each ticket sold? That's exactly what I found in question 13, which is the slope, so $2 per ticket. Try question 10 and 11, make sure you bring that to class.